Hey everyone, welcome to this video all about Azure Kubernetes Service high availability. But first, as always, if this is useful, please go ahead and give this video a like, subscribe, comment, and share. So I want to walk through how I can think about making my deployments to AKS resilient, highly available to meet my requirements. Now, when we talk about availability and resiliency, we think of a number of key terms. I wanted to just quickly cover because they're going to dictate what does our solution need to look like. So very often you'll hear about, for example, RPO. So that's my recovery point objective. So essentially you can think about that as what is the most amount of data I could possibly lose? Like I must be able to recover within 5 minutes. So an example that could be, for example, 5 minutes. So I can afford to lose 5 minutes of data in an unplanned kind of disaster. Then we'll hear about things like recovery time objective. So this is the amount of time I have to actually get up and running. So maybe in, again, an unplanned disaster, maybe that's kind of 30 minutes. So this is kind of how much data I can lose. This is the amount of time to kind of get running. And then you might also hear of RLO. And that's the recovery level objective. So this would say, for example, well, what is it I want to restore? This could be, well, I want to restore an entire VM. This might be, hey, I want to restore a particular database or a particular item. So this is more around kind of that granularity of exactly what I want to be able to bring back. And then you'll hear things like an SLA. So that's, well, what is my overall uptime of a solution? And that, for example, might be something like, well, we might say 3 nines, 99.9. That gives you a certain amount of downtime per year, per month, per day. So I need to understand when I think about my workload, what is it? Because maybe I can only afford to lose 5 minutes of data, but you know what? I can take 4 hours to get up and running again. My recovery time objective could be 4 hours. In which case, I don't really need a hot standby. As long as my data is being copied at least every 5 minutes somewhere else, like a replication, I could just redeploy my compute, bring it up. I have plenty of time. Whereas if my recovery time objective was 5 minutes as well, I need something sitting there waiting so I can very quickly get things up and running. So I need to understand what is my requirement. Now, once I understand what is my requirement, yes, we're going to talk about AKS, but a key point is you have to consider the end-to-end solution. If you just think about AKS and hit resiliency, that may be meaningless. For example, I might have an on-premises location. I might be using things in Azure. And maybe as part of that, yes, I have kind of my AKS cluster. But maybe there's kind of a load balancer as part of that solution. Maybe the stateful is in a database. Maybe I'm connecting to that and I have to use it via something like ExpressRoute. So I'm connecting kind of those networks together. So I have to understand every single component along the way. When I think about my overall resiliency, don't just think of AKS. Make sure you're thinking about, well, okay, AKS is one component. What about the load balancer? What about my ExpressRoute, my gateway, my database? Just think of everything together to make sure we're not missing anything so our all-up solution can meet whatever that requirement is. And that includes dependencies. Hey, does it hook into Azure AD? Maybe it hooks into other components. They all have to be the same or greater SLA and recovery point objectives and recovery time objectives than my overall solution. Okay, so we think about end-to-end flow. So now let's start to dive into sort of the AKS, my Kubernetes, my container environment. So the first thing is, what are the constructs available to us? So as always, in Azure, we think about regions. So there are multiple regions that I can deploy to. And a region is really defined as kind of that 2 millisecond round trip latency envelope. And additionally, you'll often see us pair regions together. So those paired regions, we don't roll out the updates to those at the same time. So if there was some issue with the fabric, it wouldn't impact both of them. And I want to always deploy to at least 2 regions. I want that level of resiliency that if there was like a natural disaster, I'm not going to impact the other copy of my data, the other instances of my compute. So I always think about multi-region. That's really kind of step one. Now, if my recovery time objective, again, is in the thing of hours or days, I probably don't need an active solution here waiting. I then would think about, well, what's my recovery point objective? My recovery point is 5 minutes, then yes, I need to make sure there's a backup of the data going to the other region at least every 5 minutes, or maybe the database has a read-only replica that's at least every 5 minutes, and I'm good to go. In the event of an actual disaster, as long as I can meet that recovery point objective of 5 minutes via whatever replication or copy is happening, if my RTO is, you can spend a day to get this thing back up, I'll just redeploy stuff to the other region. But when I start getting into those lower recovery time objectives of like 5 minutes or 10 minutes, that's when I have to think about, well, I probably need the infrastructure there ready for me so I can actually meet those objectives. So when I start having multi-region deployments, then I have to start thinking about, well, how do I balance? So I might have things like Azure Traffic Manager, Azure Front Door if it's HTTP, HTTPS based. So we have regions as these units of isolation. And that's often what we think about is a blast radius. Something happens, what gets impacted? So at a region level, hey, there could be a big natural disaster, but it really shouldn't impact the other region hundreds of miles away. And there are pretty much at least 2 regions in every kind of major geography. Brazil is the exception, but even Brazil is getting an additional region kind of added. So regions. That's when we think about our main resiliency construct at a big blast radius level. Now within the region, many of the newer regions, and these even kind of going back, they're actually made up of multiple facilities. And what actually happens is they are exposed as availability zones. Now not every region has these today, but if the region you're deploying to does have them, what you'll actually see is kind of an AZ1, 2, and 3. So an availability zone has no guarantee of distance between them. That's not the point. The point is they have independent power, cooling, and communications. So again, when I think about blast radius, hey, something could happen at the data center level. It's comms, it's power, cooling. The other data centers, the other availability zones should be fine. So again, I would think about distributing my workloads over different AZs to protect myself from any kind of data center level problem. Now, AZ 1, 2, and 3 are not physical buildings with 1, 2, and 3 written on them. The way that really works is you can kind of think about within a particular region, there are multiple facilities. There's all these different buildings. Let's just say there's 4 of them. And then for any particular subscription, so let's say I have 2 subscriptions, sub 1 and sub 2. In sub 1, I have my AZ 1, 2, and 3. 1 might be there, 2 might be there, 3 might be there. For my other subscriptions, AZ 1, 2, 3, well, it might be like that. There's no correlation between availability zones within subscriptions. They're just there to provide these isolations for me as I think about my workload. So it's a per subscription mapping per region. So then I think of that as well as I'm deploying my workloads. In terms of resiliency, I would like within the region protection from a data center level outage. So if it's available, I want to think about using availability zones. Now, even within the availability zone, well, you can think about there's obviously kind of racks of servers. So I can think about, well, there's There's racks of servers with their own power supply units and switches. And these are kind of known as fault domains. So you'll see multiple fault domains within the data center. And it used to think about availability sets that would expose 3 fault domains. It would round robin the workloads. What's really happening now, that concept of availability sets is kind of being pushed aside. And what you'll often see is you set the fault domain number to 1. That does not mean I want 1 fault domain. What it means is, like virtual machine scale sets use this, use as many fault domains as you can. So if you see a virtual machine scale set of the MSS with a fault domain count set to 1, it doesn't mean there's 1 fault domain. It means it's going to spread over as many different racks as it possibly can. 5, 10, whatever makes sense based on the number of instances I have. So within the availability zone, it's then a spread over multi-racks. So again, a rack is kind of a unit that could fail. Okay, so we've set the groundwork. They're kind of the main constructs I can think about in terms of resiliency. Regions, availability zones, fault domains. And now I want to get my container workload up and running. So what does my container workload actually need? Well, the first thing we really have is, if you think about it, is the image. So containers are built on an image. I have my kind of Docker file composition, and that composition file is built off of an image that creates my own image. And what generally I'm going to do is I'm going to have a repository, a repo, call them a registry in a lot of container terms. So like Azure Container Registry, Docker has one as well, obviously. So the first thing I have to make sure is I have my image. So I want to store it in a registry. And what I want to kind of make sure is that that's available. And I'm going to talk more about this. So I need the image that I'm going to build my container off of. Now, ideally as well, I have that composition file that actually made that. So in addition, I actually want the composition file. So if I think about something like GitHub, and I have my repo here of all my code, I'm going to have kind of my Docker file. So I could always kind of remake that image file when I need it. Next, I need an orchestration layer. So I'm going to deploy containers. I need something to actually do that for me. So if I think the larger kind of now Azure perspective, I need Kubernetes. So I can think about, well, I need that orchestration. So I need that Kubernetes kind of set of orchestration capabilities running. And really, I want these two things together so I can pull the images very, very quickly. So I need this. So that needs to be available. Kubernetes, the orchestrator, needs to be available as well. And of course, when I think about Kubernetes, what it really boils down to is there's a bunch of nodes that will actually run my various workloads. So they need to be resilient and available. And then I'll have a composition file and an actual deployment file. So my deployment YAML file for Kubernetes will say, hey, I want this many replicas of this image, and I want this kind of distribution. So then we think about, okay, well, we have our deployment file. So we want to make sure that's kept as well. And also, if we think about infrastructure as code, whatever created this Kubernetes cluster, well, I kind of want that as well. So I might think about Azure Resource Manager JSON. It could be Terraform. However I'm creating this environment, I want to make sure I can recreate it very easily. So now I think about, well, I have the deployment to create my app environment. So that deployment file would say, hey, I need this image and I need 3 replicas. So then that obviously will go and create the various pods over those nodes, hopefully spread over availability zones, etc. So I've got my orchestrator, I've got the nodes I'm running on, I've got the image that builds these things, and I'm keeping track of all the various files to create the environment, to create the image, to create my app deployment, to actually create the Kubernetes and all of my worker nodes. Now again, remember there's connectivity as well. So these Kubernetes, these nodes, well, they're living on a virtual network. So in terms of resiliency, well, how am I handling, firstly making sure I have enough IP addresses for all the pods, for the worker nodes, depending on the type of networking I'm using. They might be hooking into things like standard load balancer to distribute the connectivity over availability zones. There might be express route gateways. So there's all these other components to it. And of course, then one of the huge questions we always have is, where's the state? Because when I think of recovery point objective, that's all about the state. Very often our Kubernetes environments are not stateful. They're these microservices, they come in and out. The state is somewhere else. So what will drive the RTO, the RPO, so recovery time objective, well, that's about how quickly I can recreate this stuff. But the recovery point objective is all about where is the state. So I have to understand that. Hopefully this is not stateful. My state maybe is separately in something like a SQL database or Postgres or Cosmos DB. And that is replicating to another region. That is highly available by nature of it being PaaS. So as much as possible, get the state out of Kubernetes so I'm not having to worry about that. But we might need to, and I'll talk about that a little bit later on. But they're the key things that we have to think about. So let's kind of dive into each of those elements and think about, well, how do we really make this as resilient as we possibly can? So the first thing is obviously that image. Without the image, I can't deploy my service. And in terms of Azure, we think about the Azure Container Registry. Now there's different SKUs of this service. Obviously I can store the images within here, but I can also store other types of artifacts that might be useful for deployments. I can even, for example, submit my composition files and it can watch. So based on the image it's built on top of, if that image gets updated, it can rebuild my image. So I don't even have the local tooling required. It will go and build my image for me. Now, ideally, I want this close to deployment location. I.e., if I am deploying in East US, I want my container registry in East US as well. Now, the nice thing about this is with Azure Container Registry, if I use the premium SKU, I can have replicas. So of course I need my images highly available if I have to redeploy my environment. So if we jump over for a second and look, so if we dive in here, if I actually go and search for my container registry, so I have my little Saviltech registry with one sad little image in it. My bad father with just pictures of me and my son on roller coasters. But as part of this, what we can actually do is if I go and look within here, let's go and find this. So services, I have replications. Because I'm the premium SKU, I can actually go and add another replica. So I obviously pay for it again. So for each replica I have, I'm going to pay money for that. But I can light up replicas in other regions. So I could have, hey, if I'm going to fail over to West US, for example, well, I could go ahead and add a replica in West US, hit create. So now my registry would be replicated. It's asynchronously, but it's going to keep that up to date as I submit images. They'll also be in West US, ready for me to kind of fail over to that. So that's an important point. So if I think about, well, what do I need to function? Obviously, I need my images there. Without my images, there's really very little I could do. Now, technically, if I had my composition file and I'm building off of a standard image, I could just rebuild the image. It wouldn't be the end of the world. So in that case, I would want to make sure, well, what I'm replicating is whatever my repository is, be it GitHub or Azure DevOps, that natively is just highly available between regions in that geography anyway. So an absolute worst case, if I didn't have my registry, as long as I have my composition file, my Docker file, I could probably recreate my images. Again, if all the artifacts required, maybe my app source code is in here as well. I mean, there are other things I would have, obviously my app code. Technically, if I have the app code, I can recompile it. If everything else is kind of a standard, I can bring it all together to recreate my image. It will slow me down a little bit. And again, that comes back to my recovery time objective. The more things I have to do, the longer it's going to take me to get up and running. We think about having that registry again close to our deployment. And that's the great thing with Azure Container Registry. It's in the same regions as where I'm going to deploy my containers to. What that means is when I actually go and do my deployment, if you think about what has to happen, the worker nodes here have to pull down the image from the container registry. So if the container registry is in the same region, it can pull it down very quickly. And there's even some cool stuff they do behind the scenes to accelerate that. But that's going to give me the best, the fastest experience to kind of spin these things up. As I mentioned, this can also do the builds. So this can actually, I can submit my actual composition files, and it can automatically rebuild for me as new versions of the base image are released. So that's the image. Okay, great. So the next thing is the orchestration. So this is Kubernetes. Now, if I think about what's involved with Kubernetes, I'm not going to go into a huge amount of detail, but just super quickly, I can think about that the main brain of it is kind of the Kube API. So we have this Kube API server, and this is the kind of RESTful interface through pretty much everything talks. So that's kind of the main brain in a way. And what this talks to is an etcd database. So that's where it's storing the state. Now the next component, I have kind of a Kube controller. And there's various controllers that make up the system. And then we actually have the scheduler. So the scheduler's job is, hey, when I do a deployment and it's saying, hey, I'm creating these pods, the pods go into a kind of a pending state. It's the scheduler's job to say, hey, look, there are these pods that are pending. I need to actually go and get them running somewhere. So the scheduler will actually go and make those a reality. And that scheduler has to follow a bunch of rules, like I can set preferences and predicates about anti-infinity, about requiring certain components, and its job is through preferences and predicates to work out where it can actually put them. Now, through all of this, then there's me as kind of the person doing stuff. So I'm at my machine, and I'm running kind of the Kube control application, and it is talking to that API scheduler. So that's how I actually go and request changes and do various things. So all of that piece there is essentially Kubernetes. So that's the control plane. Now, when I talk about AKS, that is just all done for me. I don't really have to do manage with that. It's auto-managed, and I'm going to talk about that. But that's not something I focus on. And then my containers have to run somewhere. So what we then have are node pools. And my node pools are essentially VMs. So I can think about, well, it's going to be a VM, and I'll have multiple of them. So I have my virtual machines, and obviously kind of there's an OS on there. It's going to have kind of the container D is the default now, container runtime. Then what it actually has is kind of this kubelet. It's going to have that on all of the nodes. The kubelet is how it actually talks to the Kubernetes environment to actually find out what it should be doing. It gets the various instructions. And then within there, within that VM, it creates the various pods. So it creates a pod, and inside the pod, it runs the container. So generally it's a kind of, I say it's one-to-one, one container to pod. That's not really the reality. There's always at least one other container. It's a sidecar that owns the networking for the pod. But you can think about it from your workload perspective. It's one container per pod. So I have these components. Now there is also a network. There's a kube proxy running in these as well. And the kube proxy is to enable actually the exterior connectivity to each of those things. Now by default, if I do nothing else, the first node pool is kind of known as the system node pool, because there are other things that have to run for Kubernetes that will run in this node pool. And the system node pool by default always has to have at least one node in it, because it has to be able to run those functions. Now I can add additional node pools. So if this was kind of my first node pool, I could then add one or more user node pools. And that could maybe have a different definition of nodes. Maybe it's a different type of virtual machine. And those I can actually scale down to 0, because I don't have to have those. If we actually go and look for a second, let's have a look at one of these. If I actually jump over to my environment, let's look at Kubernetes. So I have two. Now what you'll actually notice is one of the cool things of AKS is you can actually stop AKS now. So my KubeNet one, you'll actually see I have this one node pool. It's going to be the system node pool, but it has a node count of 0. The reason for that is it is stopped. So I can actually stop it now to stop paying for it. Here, if I go and look at my other cluster that is actually running, we can see I have one node pool and I have 2 nodes running in it. And I could do things like, well, I could scale it, I could upgrade it. But if we look at the workloads, well, here we can see there are some core workloads here. So if I look at the pods, I can see the kube proxy that's going to be running on each node. I can see core services like the core DNS, the tunnel front. So there's all these components. So those run in the system node pool, which is why by default, I have to have at least one node in that system node pool. But again, if I stop the cluster, well then I can scale that down, essentially stop paying for it. So that's from a key component perspective. Yes, we have the nodes and I can run my apps as well on that system node pool. I want to put in a different namespace typically for tracking, but I could put my workloads there, but I can also create different additional user node pools that maybe have a different spec for the virtual machine, maybe ones with GPUs. Maybe I have Spot, so ones that are not that high priority, but I want to do it as kind of cheaply as possible if I can. So they're the components when I think about my Kubernetes. And of course, from that networking, there's different specs. There's CNI, where the pods get IPs from the actual virtual network, and there's KubeNet, where it's NATed. And you always have to think about, well, what are the actual number of IPs I want? Obviously, if I run out of IPs, things are going to stop working. When I do things like upgrades, we have this max surge. It will actually add a node. If the max surge is the default of 1, it will drain it, but it will add an additional node while it's upgrading the cluster. Well, that uses additional IP, quota in my subscription. I have to make sure I have enough quota to support that. I can increase the max surge. Maybe I set it to 2 or 4. So it would create additional nodes using up more quota from my subscription, using up more IP. So I have to kind of think about those things. So if this is my environment, what do I need to think about from a resiliency perspective? This is free. So we have the Kubernetes cluster. Now, the first thing I can think about then, well, if it's free, what does that mean? Now, all of the components in this cluster are highly available. They will self-heal if something does go wrong. But they are a certain version. So I can think about, well, there are times where I will need to upgrade the cluster. Now there is a certain inherent risk. It's very, very small, but there's certainly a risk to that. So one thing I may have to consider is, well, during those cluster version upgrades, am I okay potentially with everything being part of the same cluster? Now I would typically, at minimum, think about having separate clusters. I would maybe have a dev cluster and I would have a production cluster. So I could do things like test the cluster upgrade. Now, potentially I may need to go beyond that. Depending on what my risk tolerance level is, even in prod, I may break that out into separate clusters. We may do something like a blue-green. So blue-green is where we essentially have two clusters, two sets of nodes. I put the new version of my workload onto green, test it, and then make green production instead of blue. I switch them around. Now, there are other types of deployment patterns. There's things like rings. I can move people over gradually. There's canary, where again, I do the similar type of thing really, but it's more based on, rather than defined sets of people, which is the ring methodology, canary is more, we'll put 5% over, then 10%, then 20%. I get more confident, I expand out who's switching between them. But depending on my deployment pattern and what is my risk tolerance, I might want to have completely separate clusters, because ultimately something could happen. I could do the cluster upgrade and something goes wrong. So I might think about a reason for a separate cluster might be, well, when I upgrade the cluster, what is my tolerance to that? I might also think about separate clusters if I have some workload that heavily interacts with the management plane. Think about something like Prometheus. Prometheus is a monitoring solution. So if I have something that interfaces with the control plane a lot, it's very, very chatty. Imagine something went wrong. I misconfigured it. So I deployed to my production cluster this great new capability, and I've done something wrong, or there's a bug in it, and it's basically doing a denial of service attack against my control plane accidentally, but I'm doing it anyway. So I might also want separate clusters if I have things kind of the control plane interfacing. So I want to test this thing. I don't just want to, even if I've tested it in dev first, well, maybe dev is a completely different scale than prod. So I want to roll out this new tool that's going to interface with the control plane heavily. I may want, again, maybe it's not blue-green, but I want somewhere different. I can test, put that into production, and again, steadily roll people out. So that might be a reason I have separate clusters. So cluster, again, is that control plane, but there might be reasons I want multiple clusters. And we generally think of, at minimum, dev, test, and prod. But maybe things like the blue-green, I want different. And of course, different clusters will also mean different node pools. They can't share node pools. It's going to be different nodes as well. Obviously, I'm going to have different clusters based on regions. If I'm in 2 regions, I have to have at least 2 different clusters. A cluster cannot span regions. So there are some reasons I would think about having more than one cluster. Now, you start to get into some border scenarios. You might say noisy neighbor. I have different workloads and I want to protect them from each other. I can just use different node pools from that. I don't even have to use technically different node pools. I can use different namespaces and different sets of quotas and permissions. There's things I can do, but it gets into this balancing of kind of complexity versus physical isolation. So depending on where you are, you may just decide, I'm just going to put you in separate clusters completely. Just because I don't want to deal with it. I don't want to think about any kind of other barriers between you. I'm just going to stick you in your own cluster. But realize, the more clusters I create, it doesn't cost me more money. These are free. but I might start wasting node capacity. The more separate clusters, the more separate node pools, the less maybe benefit I start to get about multiple workloads sharing the hardware and maximizing my utilization of it. So that can be a potential downside. Now, I did mention kind of the cluster is free. So when it's free, what I get is a service level objective. There can't be an SLA because SLA is about money back commitment. There's no SLA if it's free. So if I need an SLA, there is an SLA version. So to really meet that requirement from customers, there is this ability to get an AKS uptime SLA. So you basically then pay, and there are two versions of what I can pay for, but essentially what I get is there's one where it's a 99.95, where it will spread them over availability zones, and there's one where it's 3 nines. So you can go ahead and pay, and then you can pick kind of a higher SLA. If I pick the totally free one, again, SLO of 99.5. So that's how they really kind of balance between them. So now, what's next? So we thought about the clusters. So again, the cluster itself is highly available. It will self-heal. Now, if things do go down for the cluster, depending on what goes down, my workloads still keep running. So even if this entire cluster went unavailable for some reason, the workloads in the pods will keep running. Now, depending on the failure, maybe they won't auto-scale anymore. It depends which piece is failing. But if this is just a short-term kind of outage, and again, Azure will heal it, my app doesn't stop working. The load balancer it's connected to doesn't stop working. It's just I can't interface and say, hey, I want a new deployment. I can't manually change the scale. It won't scale out the node pools, depending on the failure. Okay, so the nodes themselves. So this is where we start getting into decisions. Now, ideally, when I think about my node pools, I want to build them on top of virtual machine scale sets. That's really kind of the default now anyway. And for most scenarios, now there's a couple where I wouldn't want to do this, but for most of them, I want the zone redundant. Now what this is going to do is it will distribute my nodes over the 3 availability zones. So if I create a node pool and I have 3 nodes in it, they would be in 3 different availability zones. Now, what that means is we'll actually use this user node pool over here because I've got enough space to add another node. So if we thought about, well, this was the node pool, if that region supported availability zones and I pick that zone redundant option, the virtual machine scale set that creates them will spread them over, this would be an AZ1, 2, and a 3. Now, Kubernetes itself will know this. So Kubernetes has this concept of its own zones. And what will happen is these will actually map to the zones. It will understand, well, this is kind of zone 1, 2, and 3 in terms of fault domains. Why that matters is when the scheduler now decides to deploy pods, imagine I had more than 3. Imagine I had 6 nodes. So 2 of them in each zone. Well, what it will do is it will automatically, I don't have to do anything else, it will try and spread them over the, so if I deployed 3, it wouldn't go 1, 2, 3. Now I've got 2 in an AZ. It will try and maximize the spread over the fault domains it knows about. Now, again, within the availability zone, it's going to do that fault domain equals 1. So even within here, it's spreading them as much as possible. But Kubernetes understands that concept of, hey, the fault domains, and it will try and just through nothing else, I don't have to do anything specific, it will spread them out. Now, maybe I should have pointed out, when I have separate nodes, these pools, they could actually go to different virtual subnets, for example. Again, they can have different capabilities. Different node pools is something I may want to do from that noisy neighbor. So why would I have different node pools? So if I do have maybe different business units, I have different apps. Yes, I can use namespaces. Yes, I can use C groups. I can use quotas. But there's a certain complexity with logical isolation and control compared to just you get this group of nodes, you get that group of nodes, go nuts, I don't care. So that's why I might have different node pools potentially. You're balancing logical isolation with kind of the physical isolation. But just through doing nothing else, if I deploy that in a zone redundant fashion, it's going to handle that. Now, the only reason I maybe wouldn't do this, imagine I was using managed disks. Managed disks have to live in a particular zone. They're created in a zone. And I can't then have a pod in one zone accessing a managed disk in another zone. So there's this potential weird scenario that could happen if you hit capacity in one zone where it's starting to scale and do some weird things. Like it's very rare. It's a deeper discussion, but there is a potential for that. So there are some times, depending on the type of persistent storage I'm using, if I had state and I was using managed disks, which have to live in a zone, well then if it created a pod in a different zone, it wouldn't be able to get to the disk. So that's maybe a scenario where I wouldn't want a zone redundant AKS. Instead, I would create 3 AKS clusters that are zonal. One cluster's pinned to zone 1, one zone 2, one zone 3, and then I'm guaranteed they'll always be able to kind of get to that persistent storage. Again, it's an edge scenario. That's really one of the only reasons I wouldn't want to just let AKS handle it for me. But if I'm not using stateful managed disks, just use the zone redundant. It's really kind of your best effort there. Now, I'm going to at least have generally a user node pool. If it's a small dev test, I could just use that basic node pool that's built in for the system. I can put my own workloads there. Again, just remember to use a separate namespace kind of at minimum on that. So what if a node pool gets sick? AKS will actually heal it. So the first thing it will do if a node is sick is it will do what fixes nearly anything. It will turn it off and on again. Etch a sketch of computers. It will reboot it. If that doesn't work, it will re-image it. If that doesn't work, it will just build a new one in its place, tear this down, and build up a new one. During cluster upgrades, so I mentioned the cluster upgrades. There's two parts to a cluster version. There's the control plane. I upgrade that first. Now, if I'm using the portal, it just does it separately anyway. I have to upgrade the cluster, then I go and upgrade the node pools. If I use the command line, I have to specifically tell it, hey, just do the control plane. But I think that's going to change in the future. Now, when I'm doing an upgrade of the cluster, again, I mentioned kind of that max surge construct. Max surge says how many extra nodes can I use? By default, it's 1. It will do 1 at a time. So it would add a node during the cluster upgrade, drain this down, run the pods on here instead if it needs the capacity, upgrade it, then go to the next one. I can set that to a higher version. Again, I have to consider my overall quota, what I can actually handle for that. But they're going to kind of try and heal themselves. It's got that resiliency built in. If I actually look at, when I talk about that versioning, if we jump over, so I can quickly kind of see, if I look at the overview, I can see my Kubernetes version up here. I'm 1.18.10. I can also go to my configuration. And here I can see my Kubernetes version. I could upgrade to 1.19. So if I did this upgrade, it would upgrade the control plane. Once the control plane upgrade was finished, then I would go to, I'm going to go node pools, scroll over, and I could just select this node pool, and then I can say upgrade. Now, because it's already running the same version as the control plane, there's nothing to upgrade to. But that's what I would then go and do. Now, again, you could argue there's a certain inherent risk to that, upgrading this. So this is where maybe I have, once again, a different node pool for, again, that type of blue-green switch over between them. So I also have that capability. Now, again, it does monitor these things. If it saw it was unhealthy, it would roll back and not carry on. It's doing those health checks. So it's pretty resilient from that perspective. But realize there is kind of that version happening there as well. Hit the wrong button. So think about my node pools. So from a resiliency perspective, different node pools might be used, separate noisy neighbor, potentially separate risk doing things like cluster upgrades, where the kubelet, for example, is being upgraded. I can do that. But the key point for resiliency, use zone redundant. Obviously, I need at least 2 nodes in my node pool, ideally 3, so I can use all 3 availability zones. The reason 3 is so popular is then even if one is down for maybe maintenance or something just fails, I've still got some resiliency kind of built in. And often quorum requires 3, so I can have a majority. It's hard to have a majority with 2. They can each get 50%. So ideally, we would have 3 nodes. We're going to spread them over those different fault domains. And again, Kubernetes will see that. There's a topology.kubernetes.io/zone. So it'll actually see those. And not all regions have zones. So you'll just see kind of a east-west 1, 2, 3 type thing. But if you actually have availability zones, it will actually say zone 1, zone 2, zone 3 as part of the name. So I'm in actually South Central. So in South Central, I actually don't have availability zones, so this won't look particularly good. But we can at least see what it thinks, and you can at least see kind of the different things it knows about. So if we go here in the Cloud Shell, and if I just quickly paste, so this is looking at what are the failure domains that it knows about. So you notice it says zone 0 and zone 1. Now, if it was availability zones, which this is not, it would actually say, for example, East US 2-1. But it's not saying that because I don't have availability zones. I just have regular old fault domains. So in here, it would actually say like East US 2-1 instead of 0 or 1. But it at least knows, hey, they're different fault domains in terms of within that particular region. And then what I'll see by default the scheduler will actually do is it will at least distribute them over those 2 zones. So I have a deployment from my mouse, and paste. So we can see I have a basic deployment and it has spread them out over the 2 different nodes, node 2 and node 3. So it distributed them in kind of that best effort. So it does that by default. I don't actually have to do anything for that. It's going to automatically kind of spread those out for me. Now, during my actual deployment, so I can think about, okay, control plane is resilient. It's HA, it's done for me. I've deployed my nodes and I've used zone redundancy, so they're redundant. My deployment, well, I need to make sure I have replicas. It's no good deploying 1, it's not resilient. So I would think about having at least 2, ideally 3 replicas of my workload, and they will get distributed. Now, as part of deploying that, I have to say how they get updated. So what you want to use is kind of the rolling update. And as part of that, you can say, well, how many at a time is it allowed to update? How many extra pods will it create to balance so I don't lose capacity? Actually, if I jump back over to this, if we look at, I've got a deployment in here. So we can close this down. And if I actually go and look at my workloads, so this is actually really cool. You used to have to go into sort of Kubernetes to get up a different portal. You really don't have to do that anymore. I can just see all of my deployments from here. I can see I've got my bad father. And you can actually see my strategy type is rolling update. And then we can see the maximum number I'm allowed to have unavailable, and then the max surge. So the max surge is how many it will add maximum, and the max unavailable is how many I can have unavailable. Now, I've only got 2 replicas, so the max unavailable rolls down, the max surge rolls essentially up. So with 2, it means I can have none unavailable, but I can add 1 extra. So we'll always do 1 at a time, is essentially how this will work. So make sure you understand the max unavailable, the max surge, so you set those so you don't block yourself. Like, it won't let you set them both to 0. It means I would never be able to update it. I can't not be allowed to add any extras and not have any unavailable. I'd be stuck forever. So you always have to have one of them set to something. So either, hey, in my case, because I only have 2, well, it will roll down the max unavailable, but it's allowed to add 1. So there'll always be 2 because it will add 1 extra to then counter the one that it's currently upgrading. So that's when I think about my workloads. And again, you have to balance that. So that's my workload, my deployment. So my deployment is now being balanced over the nodes. Make sure you have a standard load balancer. So it's going to, AKS will do that for its component. It's going to use a standard load balancer. Standard load balancer supports being zone redundant as well. Again, I think complete end to end. I don't want to add in some single point of failure. So make sure everything matches that. I don't want to have some reliance on something that's in one zone that could then be a single point of failure. So my workload, I've got my replica set behind the scenes. That's distributed. Now, I mentioned the scheduler will automatically see the different zones, the fault domains that Kubernetes knows about, which AKS tells it about the availability zones. It will see that, will automatically spread it out. Now, I can actually drive that behavior a bit more. By default, it's best effort. I can actually use the selector spread priority to say, well, it must spread them out evenly. If it can't, fail. For example, imagine this zone was full and it had to scale out. If it can't keep them exactly balanced, it would actually fail the operation rather than creating it here instead. Now you might say, why would I want it to fail? Well, so I know. If it just, okay, I can't create it in 3 where I should, I'll create it in 1. You may think you have a nice balance between the availability zones when really you don't. And so by having it fail, by having that actual selector spread priority with a predicate, which is an absolute, rather than a preference, which is a desired, it will actually fail, and then I'd know about it. Now I can have auto scale. For the pods, I can make my pods auto scale based on metrics. For example, CPU. Hey, if it hits a certain 90%, for example, add more pods. I can have auto scale for my nodes as well. Now, this is going to be based on pod status. So the auto scale for the actual nodes will be driven by, hey, I have pods pending that the scheduler can't schedule. There's no capacity. So then it will actually go and add new nodes. If I've enabled auto scale for the nodes, it will add a new node. Then the scheduler can go and schedule the various pods. So I can do scaling at both levels. I can auto scale the pods based on metrics, and I can auto scale the nodes based on pods pending but can't get scheduled. Now it can also go the other way. It's a lot more hesitant to go the other way. Things have to be like empty for 10 minutes and not doing anything. It will only ever pull 1 at a time at the node level. So it's very, very careful to not risk jeopardizing the overall performance. So it will pull kind of 1 at a time. Now, I did mention kind of state. Ideally, I want to think about the state not being part of Kubernetes. In an ideal world, when I think about my all-up solution, I would try and put my state in something like a database. Azure SQL Database, the Azure Managed Database with Postgres, MySQL, MariaDB, Cosmos DB. Let that have the state. If I have to have state, well, then I have to make sure that state is available as well. Now, there's different types of state I can have. So the way that works is I have the kind of the persistent volumes, and those persistent volumes will map to a certain provider. Now, today that's really kind of Azure files. or kind of the managed disks. Azure Files is very good if I need multiple accessing the same storage. So I have a persistent volume claim from a certain pod, for example, that maps to a persistent volume that it goes and creates. Now for Azure Files, I can do things like GRS. So it could go, again, I always think about the resiliency of this. So that could go and asynchronously replicate it to another region. Managed disks have nothing like that. So if I'm using managed disks, I need to have some kind of solution to replicate my state somewhere else. So I need to make sure I'm considering that as part of my all-up solution. But as much as possible, I would try and keep the state out of the Kubernetes. Try and get some PaaS service to do that job. This is going to make your life easier. But, I mean, you can. If you need to do it, again, Azure Files, I can actually have multiple connecting to the same one, so I can actually have a shared state area. Or I can use Azure Disk, and then I need to think about, well, how will I make that resilient? If I need it in another region, how am I doing that copy? There'll need to be something else going and taking that and making that available for me. Also, when I think about resiliency, I mean, make sure you have limits in place. Make sure you can't have some workload just go nuts and take up all the space. Again, scaling can help with that. Both the horizontal pod autoscaler, the HPA, and then the cluster autoscaler. I can have different namespaces, different node pools to isolate that noisy neighbor stuff. But just make sure you are thinking about the update behavior, that rolling update, getting all of those things. What else? If you're concerned potentially about maybe poor configurations of like the pod, there's actually something called a pod disruption budget. And a pod disruption budget lets me say, hey, you're only allowed to ever drop down to 2 instances of your pod. And I tag it on a namespace, and I tag it by selectors to match different workloads. So then even if they mess up the configuration, they cannot drop below a certain number. So I can make sure it's always available. Now, the pod disruption budgets can also be evil. If I do them wrong, it can cause me problems. For example, if you set, for example, I always have to have 2 instances, but there's only 2 instances, it can never drain. And then it can never upgrade. So you want to make sure you have a pod disruption budget, but make sure it's a sensible configuration. So it ensures I meet a certain level of resiliency, but I don't set it to some silly value that means the cluster gets stuck. I'm not setting it to the same value as the total number that's running, because then it can never scale anything down. It will actually cause me problems. Make sure you do think about the networking. Make sure the subnets are big enough to handle all the workloads. Obviously, if the networking doesn't work, I can't get to things, no configuration. Think of that end-to-end complete configuration. And I think really that's the key thing. I think about levels. It's almost a ladder you can climb. So I can think about, I could start with, I guess if we think super kind of simply, I could just, my first step could be backup. I could have a backup and restore. That could be just the state. Because remember, I may not need to back up the containers themselves, as long as I can recreate this environment. And what is everything we have here? If you take out state, forget about the state for a second, what is it I have? All I have here is potentially an Azure Resource Manager JSON file or Terraform file to create the cluster, create the node pools. Then I have a Kubernetes deployment file, a declarative to say, I want these sets available with this service for the networking. So it's 2 files, an ARM deployment file and a Kubernetes deployment file. And it needs the image to push out. So I have my registry, which worst case I could recreate if I also had my Docker file. So in a worst case scenario, I can just recreate everything as long as the state is somewhere. So in an absolute kind of lowest level, I can just think about backup restore that may involve kind of a recreate of compute. That could be kind of level 1. Moving up from that, I can think about, well, make sure I use availability zones. That gives me kind of some blast radius protection, multiple nodes in my node pool. Moving up from that, well, maybe I also have multi-node pools. So now I've got maybe some resilience at the noisy neighbor. There's resilience if I do some node pool upgrade and something goes wrong. I have some protection. Then I think about, well, multi-clusters. Now I can think about, well, if something goes wrong as part of the cluster upgrade, the clusters are separated, it gives me resilience there. And then I can think multi-clusters across regions. That would be in region. So I can kind of move up these levels to really increase it. And where I get to is this is obviously the best recovery point objective and the best recovery time objective. So it gets better. It goes up. I get better values for those, which means the numbers get smaller. What it also means is the cost goes up. So it's really proportionally. Now you might also argue what also goes up is complexity. But it depends on my requirements. Again, there's not a right or wrong answer on this. I have to think about what is my need. My need comes back to the application. That's going to drive all of this. Everything really comes back to you have to understand from your applications that you're running, what is my RPO, my RTO? That's going to drive, well, what do I need to do here? And really, it's the recovery time objective that would drive a lot of this kind of decision and that SLA, that resiliency. So my recovery point objective, that might be super low. I cannot lose data, but I actually don't need to be up and functioning for a day. So the recovery point objective would drive how I replicate the state and how often I replicate the state. And again, if the state is not in the Kubernetes cluster, it's in a database. So that database is asynchronously replicating at least every 5 minutes. If that was my recovery point objective, I'm pretty good. If my recovery time objective is huge, a day, this is fine. I can just recreate stuff. But as my recovery time objective gets lower and lower, I have to start looking at more and more resiliency so I can meet that, so I can get up and running that much faster. Again, it's going to cost me more the more node pools I have, the more clusters I have, because I'm then going to have more node pools, especially across regions. Across regions, then I think about load balancing, like traffic manager or front door, the geo load balancer, and it gets more complex. I also remember about the replicating of my Azure Container Registry. GitHub, Azure DevOps, they're replicated already for me. That's kind of handled. So that was kind of the sum. I mean, really just think about, depending on your requirements, from a blast radius, I generally think minimum use availability zones if they're available, at least 2 nodes, ideally 3. It's automatically going to balance between them. The cluster is HA on its own. But I can think about, well, there might be reasons I want different clusters. Again, when it upgrades, there's a slight risk. If I have components that are very chatty to the control plane that might cause a problem, maybe I want a separate cluster there. Then I think multi-region, depending on what is kind of my SLAs, my recovery time objectives, things like that. But again, it's the state that matters in terms of that recovery point. Most of this other stuff, as long as I have the deployment files, I can recreate it. So I hope that was useful. Some things to think about. Just remember those key constructs, and good luck. Till next time, take care.